Okay, so we will start in a few minutes. Okay, let everybody join. Good morning, everyone. Okay, so let me start this stuff. Let me first share my PPT. Okay, wait for a minute. Yes, is it visible to everyone?
Yes, sir.
Okay. So, in the last lecture, we have finished the chapter number 3. Okay, I think you have aware about that. Whatever that assembly level language program, why assembly level language program required. Okay, what are the different type of the assembly language program for the different operations? That we have also discussed in the last lecture. Okay, let me connect my hands free so it would be better for recording and all the stuff. Yeah. So it's audible. Somebody give me the confirmation. Is it audible? Hello.
Yes, sir.
Yes, sir.
Okay, yeah, yeah. Thank you, thank you. Yeah. So in our last lecture, we have finished the chapter of the assembly level program. Okay, we have done different programs regarding the multiplication, regarding the copy and paste, and several stuff we have discussed in the last lectures. Okay. Now, what we need to kind of do over here, that we need to start a new chapter, and that a new chapter which is going to be a task of micro program control. Okay. Today also we have the another lecture we have. So in that another lecture we will do one of the practice of that particular chapter. there are one exercises there in your canvas, and then after we'll go with the rest of the chapter and then kind of the rest of the topic that we are going to discuss over here. Okay, so first of all, in this first lecture, let me start with the chapter number 4. So in the chapter number 4, what are the topics we have, which is a micro program control. First of all, this chapter related with the micro program control. So hardwire control, if you have remember, whenever we have designed a control unit, okay, in a second chapter their base has been started with that. What are the machine cycles? What is the control unit? How control unit work? How control signal generated? So at that time we have discussed the hardwire control system. Meaning of that, whenever you design a such system where the control unit is a fix, it is made up from the fixed set of logical component, then we can say that's going to be hardwired and it's not going to change anytime. Another type of the control unit, which is a micro program control unit. Okay, that can be changed as per your requirement. Like if some new instruction is going to be added, so you can change it your stuff. So likewise, if there are a modification is there, some new input output going to be added, another instruction, and so if you want to change it, or if you want to design it with the micro program base, so there are another type of the control unit, which is a micro program control unit. So we are going to discuss over here, that's the base part, that how this micro program control unit is going to be work. Okay, and for that there are stuff which is started like what do you mean by control unit, what do you mean by control memory, and the respective definition, that how we can just identify what are the different tasks is there, what is the difference between micro program control and I can say hardwire control. Okay, what are the different micro instruction, micro program sequencer, design of that, and the instruction format. So related to micro program control, we need to discuss over here. While in a second chapter, we have discussed about the hardware control, which is a fixed instruction, fixed set of the rules, and you need to do any task with related to that. So that we can say the hardware control. Okay. So under this chapter number 4, we need to, by and large, we need to discuss on what is micro program control unit. Okay. So first of all, what is control unit? That's the same definition we have discussed in the second chapter. That control unit is a component of computer's central processing unit that directs the operation of processor. Okay. So control unit is a central unit, or we can say central logical block, which is going to generate different signals that can be controlled at different logical blocks like memory, ALU, IO devices, and your control unit tells to all of them that how, when you need to on, when you need to off, when you need to share your data, when you need to store your data. So as per the program's instruction, that my control unit will give the instruction to all these logical blocks. Okay, so that's the basic task of the control unit. This is a stuff that we have already discussed. If you remember, there are control logic gates, there are some decoder is there, there are some sequence counter is there, there are a sequence counter, there are some increment, clear, clock signal is there, as well as there are an instruction register is there. Just a second. Okay, so these are the stuff that already we have discussed in chapter number 2. Okay, so the chapter number 2, that hardwire design we have discussed, in which there are instruction register is there. Out of that instruction register, there are I can say initial 0 to 11 bit, which is applied for different instruction. Like we have discussed so much stuff like memory reference instruction, input output reference, input output instruction, non-memory reference instruction. So that all going to be decided from this bit available in this instruction register. Okay, so this is a stuff actually we have in a hardwire, where There are some memory, and from the memory there are some data has been fetched and that data is stored in an instruction code. As an instruction code, data is come into your instruction register, and it will give the different set of the information to your combinational logic circuit. Over here there are some sequence counter is there, which is continuously changing their count, and one by one machine cycle is going to be executed from that. So we can say overall this is a hardware design. From that there are some unit, there are some block is there which is generating a control signal, and it is the stuff is going to be fixed, that according to 0 to 11 bit, according to that 12, 13, 14 and variant of that, there are some sort of instruction is going to be fixed. You can say if they have fixed, like you can do the ending and complement of the logic function only, just for example. If they have fixed that block, and if you want to use something else rather than that, like you can say you have or is there, and is there, and not gate is there. This only 3 gate is going to be available is there. But now if you are telling that I want to do the XORing, so we can say XORing instruction is directly not available in this hardware design or in hardware design. Why? Because the block or the control signal generated by that control logic blocks, it is a fix for the instruction related to add, and or, I can say. Okay, addition, ending, and or. If you say XOR, so you need to write a program for that. Under that program, your AND, or the NOT gate is going to be included. Okay, and then same thing we have done in our assembly language program also. Like you are having, just considering you have a 2 function only, AND and complement. So how you design XOR gate. So this type of the instruction you need to write it down. Okay, that we can say that's the rule of such type of the hardware stuff. While in a microprogram control, that type of the instruction is also going to be possible to give as a base instruction. Like you are not going to limit it that only this instruction you have. No. In microprogram control, you can define your XOR function also. You need not to write an entire assembly language program for that. That is assembly language program calculation with that. It's taken care by your microprogram control logic block. And you need not to write the separate instruction for that. Okay, that's the basic difference between that we can say hardwire and microprogram. So microprogram control will be like this one. So it is a similar type of the stuff. We can say there are some sequencing logic is there, and there are control address register is there. There are some control memory is there. Okay, and according to the read instruction is given, whatever the register mentioned in this one, it's going to be give the output in your system. Okay, just for example, it will be look like this one. So what is inside the control memory? It will be like fetch cycle, cycle routine, indirect cycle routine, interrupt cycle routine, end routine, add routine, input output F routine. So these are the different routines are there. Or we can say there are a set of code, set of hex number has already defined for such type of the instruction. So whenever you say add the 2 number, so for that you simply says ADD, ADDB or ADDC. So what actually that stuff is going to be do? That's directly do that it is executed that loop or executed that routine, okay, from your regular program, and then it will give the result of add. So now you need not to write a separate assembly language program for that particular function. You just need to write one mnemonics ADD. And with respect to ADD, it will automatically do that stuff by going to that routine, and it will give you the answer of that execution. So in the microprogram control, under the control memory, this type of the subroutine going to be there. Okay, so that you can, this is for understanding that what actually can be happen inside of that. So you just need to give the control address, that you go to this address, execute this routine, and again go back to your original stuff. So these are the stuff going to be happen in a microprogram control. Whenever you have doubt, please feel free to ask and interrupt me and ask me the query. Okay. So if we can compare that we are having a several stuff, but when there are stuff is going to be, whenever the stuff is going to be happening to generating a control signal. Okay, when the control signal going to generate it. That's the main program, or we can, that's a main question over here. So you can say we have written some higher level programming. You have used some higher level language programming. Let's say you have done in embedded C. Then whatever the instruction you have written in embedded C, ultimately it's converted into the assembly level. Okay, there are assemblers there which is identify each and every instruction from that assembly, and it will convert into their hexa number and all the things. So we can say from the higher level user program, first it will come to the machine instruction translation, that we can say assembly type of the stuff. Then it is converted into the micro program. Micro program, I can say like this stuff, I can say add XOR. If I have written XRA, so XRA is a minor, we can say there is a micro program is there. To execute that micro program, there are micro instructions are there. So what is a micro instruction? I can say if you have written a mnemonics XRA, let's take there is a XORing function, but you don't have the direct XOR function. So what you are going to do? You are fragmented your instruction. Okay, you go to that particular loop, जैसे हमने यहाँ पे देखा, like we have discussed over here. When you write XRA, so it will go to that routine. So under that routine also there are some codes, there are some hexa number is written over there. So we can say these are the micro instruction are that which is possible, which is executed overall function of XOR. Just for example. So at that time, when you are just go to that routine and execute a subroutine, or we can say executing sub instruction on the one big program, or we can say in a big micro program. So that is going to be generated, or we can say that is a place of generating a micro instruction. So whatever the instruction written in that micro program, like if you have written XOR and there are 5 line is going to execute it from your micro program memory. So in each and every line, whenever that each and every line going to fetch from the memory, at that time there are a control signal going to be generated, and control signal give the instruction to the entire computer that under this micro program, this much block first need to on, then this much block need to off, then data is go over here to there, then data go to the complement, data go to the end. Likewise, this stuff going to be executed behind that, and whatever this stuff is going to be executed with that small data block, which is considered as a micro operation. Okay, so from the big stuff, from the user level program to the downside assembly level language, then we can say the micro program we have written for that specific mnemonics, and then the small part of that micro program that considers a micro instruction, which will make entire micro program feasible. And under that micro instruction, whatever that execution part is there, that we can say the micro operation. So this thing you need to keep in mind whenever you say where the control signal going to generate it from micro program at the micro instruction level. Okay. So we can say micro program, there are 2 stuff over here. Okay. So micro program control is a control mechanism that generates the control signal by reading a memory called as a control storage. That certain control signal, as I have told you, that in microprogram control, which is simple, it's a control mechanism that is going to generate the control signal by reading the different memory. We can say in the control storage, there are a different stuff has been stored. As I have told you, in a subroutine, there are a subroutine is there, and in each subroutine there are some set of number has been stored, and according to that number, when this number enter to your control block, it will generate the signals. Okay, so microprogram control is nothing but you need to read those routine, or you need to read those location of those routine. Okay, there are 2 stuff has been comparatively given over here: 8080 Intel, 68000 Motorola, and the CISC have a microprogram control unit, while Intel 8085, Zilog Z80, Motorola 6802 having a RISC, which is having a hardware control. Okay. Over here, there are two things that I want to give you as a comparative analysis. And no doubt it will take 5 to 10 minutes for the discussion, but you need to understand this stuff very clearly. Okay, let's say like there are two type of the application which is actually available in the market. Okay, first type of the application will be like general purpose, and one type of the application which is a specific. Okay, specific, first of all I talk about the specific purpose. If I'll say specific purpose, so specific purpose will be like I want to design a control unit, or I want to design a circuit, or I want to design I want to design some logical circuit that can control AC. Okay, that's AC is a home appliances, so I need to control the AC. So what is a task is related to AC? Like it can connect with your infrared remote. It can just give the signal to the AC. It will take the reading from temperature sensor, and according to that, it will generate some signals, and it will make the different blocks on off, fan on off. There are a sort of the stuff which is required for the AC. Similar type of the stuff. If I can say I want to design some system for the washing machine control. So washing machine control, they are having specific tasks, like whatever the button is there. According to that button, there are some set of program is there for range, spin, okay, water inlet, outlet, and several stuff. So whatever the button is over there, that much of this stuff you need to execute over there. Now AC not going to play the video, washing machine not going to play the music. Okay, that because that is not required from that home application. So rather than to spend millions of dollars as the Intel is spending for designing i3 and I processor, which is a wastage of money. If you can say you set your i3 processor in your washing machine and you design the washing machine control unit, so that's kind of the not a wise decision. So what you can say, you are going to design a controller, or you are going to design such type of the system which is having a specific task only. Okay, and after that you don't need to do anything from that. Okay, like with the washing machine you don't need to communicate, you no need to do the video streaming with washing machine. No, you require some specific task need to be executed that system. So for that, whatever the architecture you are designing, whatever the computer architecture that you are designing, which is must be having a fixed instruction, fixed stuff need to executed, and not more than that. So we can say at that time we are preferring that it should be designed from the hardware control, which is having a limited functionality. Okay, that is going to be used for that. While we can say another stuff, I'm designing any laptop or any computer. So I can say with the computer you can do anything. You can do the communication. Just a second. You can design the several stuff. You can do the you can just apply communication fundamental with that. You can kind of the set up a printer. You can set up the any other USB-based device. You can do the video streaming. You can access the internet. You can play the movie. So we can say, if I can talk about the processor, which is, or we can say computer architecture, which is designed for the particular uh, device, which is not having any we can say directly there are not, it's a bounded in their self. We can say that is an open type of the stuff. So at that time the computer architecture should not having the limited access, or we can say not having a limited resources. You need to expand there. Like this is a chip you can use is in any of the application, like i3 i7 chip you can use in your computer, you can use in your laptop, you can use this for any we can say some satellite launching system, you can use it for designing some another system, you can design it for some computer, we can say for some I can say for machinery to run this machinery. Like that is not a specific application, and we can say there are a general purpose platform is there. So the general purpose platform always required the modification, and that's why the micro program control unit which is suitable for such type of stuff. That's why There are a normal that differentiation is there. Like whenever we talk about our laptop, PC, or mobile, or we can say that the stuff, or especially for laptop, mobile, laptop and computer, PCs, we can say. So that is done from the processor. Okay, and that processor will be something 8085 and like this stuff, and it's come under the complex instruction set computer, or have the microprogram control unit that can be modified as per the input output device you have connected. While the stuff which is for the specific application, like traffic light control, washing machine control, I can say ultrasonic sensor drive, RFID devices, or we can say there are some AC, we can say that I can say AC control. So for that they have the limited functionality. So for that limited functionality, you are using a reduced instruction set computer that considers a hardware control. Okay, so there are two type of these stuff we have that actually you need to keep in mind regarding the microprogram control unit and the hardware control unit, and you must get the difference between them. I'm not going to apply my i3 chip on my washing machine. Why? Because whatever the controller chip used in a washing machine, it is very much cheaper than the i3 processor, and you require some limited facility. आपको washing machine के साथ video streaming नहीं करना है, आपको internet access नहीं करना है, or you can say not that much of the general purpose application you have. Okay, so at that time you don't going to spend the money on that much of the costlier processor. No, you need to find out some reduced or limited functionality device or limited functionality architecture. Okay, so this is the two stuff. Somebody will ask the question where the microprogram control used, where the hardware control used. So this should be differentiated. Is that understood, everyone? Yes, no? From the class? I need a confirmation from everyone. Yes or no? Have you guys got the idea? कि भाई कहाँ पे प्रोसेसर यूज करो, कहाँ पे हार्डवेयर कंट्रोल यूज करो, कहाँ पे आप माइक्रो प्रोग्राम कंट्रोल यूज करो. समझ में आता है? दो टाइप के डिवाइस होते हैं, like two type of the devices there. Okay, embedded devices and general purpose devices. Embedded devices for specific purpose only. Like you have some CCTV camera console block, you need to just do the CCTV camera streaming with that. You no need anything after that. So we can say there are a specific embedded system you require. But when you design computer, when you design your mobile, so that's the general purpose. You can do many things with that. So for that, you need to do some general purpose platform. That's, we can say, the microprogram control based device you need to design. I need I have a 51 student is there in class. I need confirmation from everyone, man. Understood? Yes, no? Only say 6 to 7 student has given me the answer. Okay, majority yes, 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 yes. Okay. So let me go to the next stuff. So under the microprogram control, that's as I have discussed, like what inside the microprogram control unit, that's the binary control variable, which is actually stored in a memory inside the control unit, which is used to generate control signal. So as I have told you, whenever there are a sub block are there, whenever there are a subroutine access are there, your binary codes, or we can say your hexa code, or whatever that control signal generated, which is from that stored binary numbers, or we can say stored binary values. If there are add is there, so whatever the add subroutine or add particular that routine, from that add routine there are some binary numbers stored, and whenever those binary number come to your system, that different control signal going to generate out of that. What is a control memory? It is a storage in the microprogram control unit to store the microprogram. So where the microprogram is stored, it is stored in a control memory. What is control word? The control word, it's the control variables at any given time can be represented by control word string from ones and zeros called as a control word. Okay, so we can say it is going to be stuff like that word, or we can say it's a string of ones and zeros. Okay, whatever the control word going to be generated from your system, which is in terms of ones and zero, which will give the instruction to the different blocks. Like I can say there are enable signal is there in your mux. So what is the enable signal in your mux? If that enable signal, when that enable signal 1, then your mux started. So 1 is the word for that particular multiplexer. Okay, and whenever that word becomes 0, then it's going to be 0. So likewise, we can say 1 is nothing but it's represented by the control word string of ones and zeros. That's considered as a control word. Control signals. It's a group of bits used to select the path in multiplexer, decoder, arithmetic unit, register, and other circuits of the CPU. Okay, so control signal definition, we all know that it's a group of bits which is going to apply in a different multiplexer, decoder, arithmetic, and according to those control signals, that block will share their information or it will get their information. Yes, they have, somebody has opened their mic. Any question, please ask me. Somebody has opened the mic. Any question, guys? Somebody has question from the class? No? Okay. Okay. So coming back to that original track. Next, there is a sixth definition of that. What is a micro operation, micro instruction, micro program? Okay. So micro operation, that's the operation performed by the CPU on registers data, detailed low-level instruction, arithmetic, logic, shift. So micro operation we can say which is a ground level, or we can say very low-level instruction, like what you need to actually perform from this instruction. Either you need to shift, you need to do some logical, you need to do the arithmetic. Simply you can say whatever the digital block is there inside of your processor, when this block will execute their functionality 1 0 1 0 accordingly. So to do that stuff, like you have array of the AND gate, 8 array of the AND gate, and when this AND gate will perform the task, it will do some calculation according to the input and generate the output. So that particular task is considered as a micro operation. Okay, micro operation, it means there are a ground level operation has been done at the lower level. It's going to be done at the level of arithmetic, logical, shift, like that. Micro instruction, which is a bit pattern stored in a control memory, specifies one or more micro operations like this stuff. It is possible like that. You can say whenever I'll say add, so whenever I'm doing the add, so it is possible that with respect to add, there are some common micro operations are there. Okay, that common micro operation will be like, I can say when I'll say add, it means there are a specific thing like that you need to on your accumulator, you need to on your bus, you need to on this particular. So whenever I can say on the accumulator, whenever I'm doing the addition, so accumulator always going to be on. So we can say whatever this operation, whatever the micro operation is there, it is going to be a common for every time. Whenever I say add B, add C, add D, add H, whenever I write add, but accumulator is going to be common. So I can say the instruction related to on that accumulator is going to be common. That we can say specify one or more micro operations. Sometimes it's going to be common instruction is there in kind of this subroutine. That also possible. Last one, micro program. It's a sequence of micro instruction which is stored actually in a control memory. Okay, so whatever your ROM is there, that ROM having that definition, that what is a micro instruction. According to micro instruction, it is just go to that set of micro operation and then it will execute this stuff. Okay, so let we will start with the stuff of the micro program, but not now, but in the next lecture. Okay, we will start with the micro program, but before going to this particular stuff, before going to this particular program, what I'm going to do, you need to go to the canvas. So there are some tasks for you related to the canvas. Let me just go to the canvas and let me just show it to you. So simply, you need to go to the canvas. Have you gone through that copy and paste task? Yes or no? Have you completed that task, copy and paste? This one? write assembly language program for copy and paste the data from 500 to 5FF to 600 to 6FF. Have you gone through this task? Yes or no? First of all, tell me. Anybody? There are 6 submissions already there. Yes or no? Mihir Gandhi, Rahul Kumar, Rishabh Raj. No. Okay. So
Not
what you need? Okay. What you need to do? What you need to do? You need to simply go to the PPT of chapter number 3. In the chapter number 3, if you have observed, we have discussed the stuff related to clear the unit. We can say clear some specific memory location. We have done the stuff for that. Where are the programs? Yeah, this is a program. Write the program loop using a pointer and counter to clear the content of hex location 500 to 5FF. This is a clear. But what I am right now talking about, I am talking about the stuff related to copy and paste. It means I am having the location. What is the location I have? I have location 50 to 5FF. Whatever the data is there in the 50 to 5FF, you need to paste that same data into 600 to 6FF. You can use a GNU SIM 800. You can use a pen and paper. But whatever the answer, whatever your finding is there, you need to write it down in a paper, or you need to design program in GNU, and you need to submit it over here. The logic of that. Okay. So the program is already that clear program is already there in this PPT. Okay, that clear program is already there in PPT. But now you need to do one step ahead. You need not to clear only, but you need to copy and paste also. Okay. So in this next 20 minutes, you need to do this program. Okay. And you need to find out the answer. And when we will come to the next lecture at 11:15 to 12:15, you need to show me the answer. Whatever your answer is there, you need to show me. And then I'm also going to try to do that copy and paste instruction, and then we will go with the rest of the topic that is remaining for this particular chapter number 4. Okay, is it okay? Yes or no, everyone? And you need to submit back to the canvas also, so please do that accordingly. Okay, so start doing that stuff. It's already there in your canvas. You can take the definition from that. You can use a GNU, you can use kind of the pen and paper, but logic need to be verified. Okay, I will do this stuff with the GNU. Okay, I'm going to do it with the GNU, and I'm going to give you the answer that how this is going to be stuff, what are the logic behind that, and then we will go with the rest of the discussion of the topic. Okay, so start doing that right now. You have a 20 minutes of time, and the answer which is expected in the next lecture regarding the same task. And once you will complete that, I'm expecting that you are supposed to submit it back to the canvas. Is it okay? I need confirmation from everyone, yes or no. So start doing that right now, everyone. Please write if you are clear with that, then yes, 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 please write it, everyone. 60 students are there. Please write yes, 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 yes. So I will get the idea. Yeah. So start doing that, and mind well, if you are not submitting into the, or whatever the logic, whatever your effort is there, you supposed to submit back to the canvas today itself. आज ही आपको जितना हुआ जो भी लॉजिक है आज ही आपको सबमिट करना है. So I required, I will ask randomly to anyone that what is your answer, what you have done the effort on that, and you need to show the answer to me. Okay, start doing that. You can take the help of internet also. How do the looping, because it's required the looping in a GNU. So how to do the looping? What are the instructions for that? Just use that. You will get the definitely answers. Start doing that. And if you complete it within this 20 minutes, so you will tell me that, sir, I have completed. So we will consider your answer in the next lecture, and we will start with that. Start doing that, everyone. You have 20 minutes of time. Yes, Gaurav. Tell me, Gaurav Tanna. Yeah, what's the question, Gaurav?
No, no, sir, no, sir. I was just
Okay, okay, okay. Yeah, somebody has tried or not? Yes or no? What are the stuff? Have you tried in a GNU? It's near about 448, and I can say 10 line program is there to do this copy and paste. Have you tried it? Yes or no? You can use the instruction like, let me give you a hint. You can use LXI instruction. You can use STAX instruction, store accumulator with a pair. You can use that one. Good one, you are trying. But those who are doing a JNU, I can say use the LXI instruction, STAX instruction, INX instruction, JNZ instruction. If you use those instruction and creating a loop, so you need to simply search in the internet that how to do the looping in 8085 simulator. So you will get the answer. Okay, so just do that. Another also we have a 10 minute of time. You can write the summary in the chat box, and then after you can leave the class and wait for the next lecture. Okay, so this is open for everyone that you write the summary of the today's discussion. Then after you write your enrollment number and leave and doing this program. Okay, we will discuss this stuff on the next lecture. Don't worry about that. Answer of this question. Yes, so I'm expecting that everybody is writing the summary. Okay. After writing the summary, you need to write your enrollment number and name, and then you can go and do this program. Okay. Yes, Mahek, tell me, Ajudia. Mahek Ajudia. Tell me, Mahek. Yeah, what's your question, Mahek? Yes, Mahek, I'm listening.
Yes, sir.
Yeah, tell me, what's your question?
No, sir, I have not question. I accidentally read
Okay,
out.
yes, done. Okay. Yes, everyone, quickly write your summary and then you can go. Okay. We have a next lecture also in the same class, batch batch A. Okay. Yes, everyone, leave quickly. I have a next lecture, next lab also. Mahek, Samir, Nirzar, hello, quickly.